will indicate the materials were received in a satisfactory condition. If there is concealed damage, save the damaged articles, including all packing material. Notify the delivering carrier immediately. Double-check each load. Finding that materials are missing or damaged once erection is underway is a costly proposition. Unloading materials is the first step in the actual erection of the building. Always have the proper equipment on hand when unloading. The site conditions, space to maneuver, nature of the materials to be unloaded, and other related factors will determine the type of equipment best suited to the situation. Ordinarily, unloading is done by cranes. Under the right circumstances, however, forklifts may be more practical and economical. One piece of equipment essential to unloading sheeting is the spreader bar. With either a forklift or crane, the spreader bar reduces the possibility of buckling long sheets as they are being lifted. When lifting sheeting, pickup points should also be protected so that the edges of the panels won't be damaged. Chokers, slings, clamps, or shakeout hooks are normally used to unload primary and secondary structural steel. The unloading equipment should be positioned at the pickup or balance points of the load to be hoisted. The weight and shape of the load determines pickup points. Never pick up a panel bundle at its extreme ends. This can severely damage the major panel ribs. A belt or protected edge should be used to avoid damaging the panels. Always pick up panel bundles at the designated pickup points and position the slings around the sideboards. Remember, damaged parts cause delays. Unload all materials carefully. Do not drop, but rather lower them slowly to the ground. A good job of planning the unloading sequence and material layout scheme will eliminate extra crane moves, extra handling of material, much wasted time, and possible damage to material. Give the crew a sketch of the placement locations and/or storage areas for the structural members, panel, trim, bolts, hardware, and insulation prior to unloading. There are two basic unloading techniques. One is unload and store. The other is unload and erect. If the erection process is going to be delayed, building materials must be properly stored so that they won't be damaged. Ground storage structural components are subject to moisture and dirt. Since structural steel is usually primed with only a shop coat, it might have to be cleaned and repainted at great cost. All materials should be placed on blocks. This will also help assembling materials and attaching them to lifting apparatus. Even greater care must be taken to protect sheeting and trim that are stored. When storing sheeting, one end of the bundle should be elevated at least 3 to 4 inches off the ground. Sheet bundles should be placed above the terrain so that air can circulate from both ends. Proper storage does not ensure moisture prevention alone. Inspection and appropriate action is the best insurance to avoid damage from moisture corrosion. Care must be taken when storing and handling insulation materials so that the facing doesn't become damaged and the fibers begin to deteriorate. Keep the material packaged and covered with a tarp until it is erected. No one should be allowed to walk on material stored on the ground. Time spent cleaning soiled materials could be better spent on erection. Job site theft is costly and irritating. Small tools, erection materials, and hardware should be locked up when they aren't being used in a field warehouse or storage vehicle. Larger items can be protected within a lighted area. A watchman might also be inexpensive insurance. If the erection of the building is to start immediately after unloading, the primary structural steel should be laid out for easy pre-assembly and setting. When possible, leave an access area throughout the full length of the building so material will not have to be handled more than once. Many erectors know that a man on the ground can work twice as efficiently as a man working in the air. It will help the builder if he can assemble as many components as possible that can be handled safely while they are on the ground. For a relatively small structure, the builder may want to erect it immediately upon unloading with a minimum amount of pre-assembly. This can minimize the amount of time a rented crane is needed on the job. It may be cheaper on smaller jobs to assemble smaller parts after rather than before the erection of the primary structurals. Pre-assemble everything possible on the ground. Ground pre-assembly is safer and takes a lot less of the crew's energy. Columns can be pre-assembled with clips, brace angles, and other miscellaneous connections. The builder will have to decide on how much pre-assembling can be done depending on the size and type of job. Rafter sections can be bolted up as they are laid out for picking. All splice bolts should be installed and tightened under unstrained conditions. Make sure all pre-installed high-strength splice bolts are properly tightened before the structural sections are hoisted. Connection bolts for miscellaneous materials need only be finger tightened in pre-assembly. All bolts, however, should be fully tightened upon completion of each connection. Always follow the manufacturer's specification for bolt tightening. Flange brace angles also can be loosely bolted to the rafter sections while they are on the ground. Post and beam end wall materials can be laid out at each end of the building. They can be fully or partially pre-assembled for tilting up into place as a unit or unit sections. Girts, purlins, eave struts, and door jambs should be broken out and divided along both sides of the building according to the requirements of each bay and rebundled if necessary for handling. Panel bundles, trim, and related components should be spotted outside the foundation perimeter for erection later. Shake out wall and roof rods in their respective bays. Run the nuts down, then back them off to clean the rod threads. Pre-assembling nuts, bolts, and washers can also save time later. Structural steel, Section 5. Safe and efficient structural steel erection begins with the first braced bay. MBMA strongly suggests that when possible, the first bay be completed from sidewall to sidewall before erection continues on the remaining framework, except for extremely wide buildings or where impractical. That includes primary frames, purlins, and eave struts, and loosened permanent rod bracing. The framework should be adequately braced with properly anchored construction tie-offs. Further, it is mandatory that the builder adequately stabilize all erected components until the entire structural shell, including the sheeting, is complete. Nearly all construction phase failures can be attributed to inadequate construction bracing. Once the frames for the first braced bay are set and cable braced, all of the secondary structurals should be installed. Once the purlins and eave struts are tied in, any permanent roof and wall bracing should be installed in a loosened condition. All temporary construction bracing must still remain in place and tight. Secondary structural connections should not be tightened until the first bay has been plumbed and aligned. Necessary alignment adjustments may be made by tightening or loosening the temporary cable bracing. After the bay is completely plumbed and aligned, the secondary structural connections may be tightened to specification, along with the permanent rod bracing and the anchor bolts. Permanent rod bracing is not recommended as temporary construction bracing or for purposes of plumbing. The quickest way to align a building is to plumb the first bay erected. Then make periodic alignment checks and adjustments throughout the balance of the structural system based on this benchmark bay. This will make all succeeding connections easier. Plumb is defined as a variance not to exceed L300. There are several accepted plumbing methods. Use a transit to achieve the greatest accuracy. After the first braced bay is completed and plumbed, the builder may continue with the erection of the remainder of the structure. Again, the temporary construction bracing should still be in place and tight in the first bay. MBMA recommends that all purlins be installed as the building progresses. This diagram reviews the initial steps of metal building erection. 1. The first interior frame is set with temporary tie-offs, shown with blue lines, in place. 2. The second frame, in this case the end wall, is fully erected with construction bracing, again shown with blue lines, in place. 3. All of the secondary roof and wall structure is installed. 4. Permanent rod bracing, if required, is loosely installed. 5. The first bay is plumbed and aligned with all connection bolts tight and permanent rod bracing, if any, snugged down. Do not tighten the rods too much. It may not be possible to pull all the sag out, especially with larger rods. 6. Erection of succeeding frame lines continues with the same procedures as described before. In order to reduce the number of lateral crane moves, it may be practical to continue with the erection of one half of the structure for the entire length of the building. Then, work back down the opposite side in the same prescribed manner to finish off each frame line. This method is fully acceptable as long as adequate temporary bracing is used throughout the length of your erection path. Once the first bay is erected, braced, plumbed, and bolted up, it becomes the basis for erecting the remaining frames. Set all columns you can reach without moving the crane, but only for those frames which can be completed or braced during the current day's work. Freestanding columns are hazardous since they can be blown over by a gust of wind. Put washers and nuts on the anchor bolts, but do not yet tighten more than finger tight. If 2 cranes are needed for erection, it is suggested to have one at the site ahead of the other to shake out the material. If 2 crews are required, the second crew can be kept busy by following up the main erection sequence with the distribution and bolt-up of fill-in materials. When all purlins are filled in as erection of the frame lines progresses, the roof bundles can be spotted above the framework, if the roof slope permits, normally under 2 and 12. This can save valuable time during sheeting erection. It also reduces the crane time. A wide multi-span frame structure will require additional men to follow up the main erection sequence with the installation and bolt-up of fill-in materials in order to keep pace with the main framing. Also, if roof slope permits, plan to spot the roof panel bundles as structural steel erection continues. The crane may not have enough reach to properly place the bundles later. When placing roof panel bundles on the structure, make sure they are spotted over the primary rafter sections with purlins blocked to avoid structural damage to the unbraced light gauge purlin members. These operations should be repeated over the entire length of the building. The remaining end wall is raised by the methods described earlier. If for some reason the wall can't be sheeted immediately after the girts are erected, girt flutter may be averted by blocking or by looping a continuous length of rope around the eave strut or end rafter and to each girt, and then secured. Walking or climbing on girts or girt clips also introduces severe stresses. The repair of carelessly damaged material is always more costly than measures of prevention. Prior to installation, plan the positioning for each girt line in order to properly accommodate the framed openings. If a girt line must be changed to accommodate framed openings, try to maintain this positioning throughout the length of the visible wall plane. This helps avoid erratic screw lines and stripped-out screw holes in the sheets. It is important to align the face of the base condition with the outside faces of the girt system to ensure proper alignment of the base for the wall sheets. This can be easily accomplished with a plumb line.